So question 10. First thing is, here we're in meters per second squared, meters per second, kilometers per hour. I don't do physics with kilometers per hour. You might recall from last year, we learned to go from kilometers per hour to meters per second was divide by 3.6. We kind of ended up memorizing that one because we did it so often. You can add that to your blue sheet. You don't need to add it to your yellow sheet because I'm not going to make you do that on a test. I'll give you correct units on a test. But in the homework, if I'm trying to make up actual numbers, and I looked up a jetliner for this and found that it did have to have that as a takeoff velocity. Okay. I think if you go 306 divided by 3.6, I think you'll find that this is actually 85 meters per second. But we need to talk about how airplanes actually fly. Airplanes fly by moving through the air. Doesn't matter about the ground, they move through the air. So I'm going to draw a picture. My art is terrible. There's an airplane, okay? Sitting on the ground. Right now, it needs to go this way at 85 meters per second to get off of the ground. But let's suppose there's a wind blowing this way at 30 meters per second. How fast is it already traveling through the air? So now it only needs to go an extra 55 meters per second to get takeoff speed. Okay? Hey, if the wind was blowing 90 meters per second, it could take off. And I think I showed you a video of that last year. Some of you got it. Okay? So let's now look at the actual question here. Part A says this. Find distance. Let's assume that all airplanes stop before they take off. VI is 0. I've never seen a plane go crazy around the runway and start going. They always come to a stop. A is 3.2. VF in part A is 85. I'm going to use VF squared equals VI squared plus 2AD and get the D by itself. And that'll give me my answer for part A. Part B is kind of cool. Part B, I'm still being asked to find D. VI is still 0. A is 3.2. But in part B, we have a 15 meter per second headwind, which means actually the airplane only needs to get up to 70 meters per second on the ground because it's already going 15 meters per second through the air. It needs less distance. In part C, we have a 15 meter per second tailwind. So in this case, it's going to need to get going an extra 15 meters per second because standing at rest, it's technically traveling backwards through the air. We need to get going faster. We're going to need to get to 100 meters per second. This is why, by the way, especially any small community airport like our Pitt Meadows Airport, you'll always see a windsock, and pilots typically, especially if it's like a field that they're landing in or something like that, they'll do a pass first to see which way the windsock is pointing. You want to land and you want to take off into the wind. Way easier. Need less room. Is that all right? Yeah.